right, in activity 3.3, we're going to be looking at minerals and their specific gravity, which is another term for density and calculating the density of the mineral. Items that we're going to need for this activity include paper clips. We will be using a balance, a beaker about half full of water. You could use a styrofoam cup, you could use a plastic beaker. Any type of cup is going to work just fine. You'll also need a calculator, paper towels, along with our mineral kits. For this activity, our pre-activity that we have set up, we're going to need sample 3A, which is going to be our pyrite sample. So I'm going to go ahead and have the students pull those out of their kits. And what we're looking for within this activity is calculating the ratio of the dry mass of the mineral versus the wet mass of the mineral to calculate out basically its density, or what we call the specific gravity, which we're ultimately going to use for identification purposes of those minerals. So students are going to go ahead and take the mass of their dry samples and record that on the data sheets that are provided to you in your lab manuals under the 3.3 mineral specific gravity. We are then going to have the students get a wet mass. Now here's where the paper clip comes into play. So we're going to turn this into an egg dipper. So we're going to fold this out. We're going to fold one arm down. We're going to make this kind of into a circle or a ring so that we can suspend our mineral from the holder. So now it is a mineral dipper, because they're going to need to suspend this mineral in the water without touching the sides or the bottom as it's being massed. So the students are going to place their beaker back on the balance that's full of water. They're going to zero out their balance, and then they're going to drop those minerals very slowly down into the water without touching the sides or bottom, and they're going to then make sure it's completely submerged without touching the bottom. They're going to go ahead and record that, what we call the wet mass of that mineral, on their data sheets. Now we have a value for our dry mass of our minerals versus our wet mass. And by taking the dry mass versus the wet mass, we can divide those two numbers, and that will give us a ratio of the dry versus wet, which is going to ultimately be the same as our density calculation. And Isaac, what did you get for your specific gravity of your pyrite?
4.6.
4.6. And Lauren?
4.24.
4.24. So there is a range there that these minerals can fall within in order to find their values. Now, Lauren's falls slightly out of that range that we would consider to be accurate for pyrite. So Lauren, what about your mineral sample do you think does not allow it to fall within that range?
If it's not like a pure or homogeneous sample, then it wouldn't fall within the range.
Right, yeah. If that sample is not a pure sample, there's going to be impurities within it which are going to throw off that specific gravity or that density value. So it's not going to be useful for us in determining the identification of that specific mineral. Where Isaac's falls right within that range, he has a fairly homogeneous sample, and that's a very accurate measurement. So as the students go through, they also have samples of galena, they have samples of calcite, barite, garnet, and azurite to go through and identify those specific values for the specific gravity and the density. And then we're going to compare those to see if we have some homogeneous samples that can be useful in the identification process. So it's through the processes of looking at all the different properties of these minerals that petroleum geologists in the field are able to look at samples that are coming out with the drill cuttings to be able to produce and predict where these hydrocarbons exist underground, along with the seismic technology we talked about earlier, that we're able to locate and identify specific spots of where we're looking for removing those hydrocarbons for further use down the road.